All right. Hi, guys. I hope you had fun at the summit. So go ahead, take out your notes from a couple days ago. I can't remember when we took these notes together. It was day 9. Oh, on Monday. We started these notes on Monday. This is what the handout looks like. And we're going to do example 5 together. I'm going to try to keep this video short and sweet so that you have the rest of the period to do work like on the study guide or work on that practice quiz, whatever floats your boat. So example 5 says these functions are the same functions as the one above. Prove it. I'm not sure what functions that they're talking about. I think these are just extra practice problems that I picked, but one of the nice things about math is that we can change the way an equation looks, but still have it mean the same thing and just make it look or put it into a structure that is familiar to what we've looked at before. So, just looking at the stuff that's underneath the radical, I noticed the first thing that both of those numbers are divisible by 125. So, the first thing I'm going to do is I'm going to factor out 125 from both of those terms. And so I divide everything by 125. And so 125x divided by 125 is just going to be x. And then 250 divided by 125 is going to be 2. And that plus 4 is going to stay on the outside. Then I could use my radical property, one of my radical properties, and separate these radicals into two different radicals. And so now when I look at this is something that I know the cube root of. The cube root of 125 is just going to be 5. So another way that I can express this equation is 5, and that minus sign, by the way, is going to come down from this from the very beginning. So if you notice, like that trailed along every step of the way. Okay. So really what we're doing here is we're just changing the structure of the equation, but still having it mean the same thing. And so now when I look at something like this, I see that I've got an odd negative function that has been shifted right 2 up 4 and has been reflected over the x-axis. So let's do that again, but with g of x. So let me change colors here. So we're going to do that one more time. So first thing I'm going to do is I'm going to take a look at both of these, and I think both of these are divisible by 49. So I'm going to rewrite this equation. And first thing I'm going to do is factor out the 49 from both of those things. So everything just gets divided by 49. Let's see, so this turns into minus 6. Bring that square root across, and then minus 3. We're going to separate those into two different radicals. Let's see, we get this. Square root of 49 is a number that I know how to do. And hopefully you guys also recognize that as a perfect square number. So the square root of 49 is 7. And so now what this is revealing to me is that I've got an even positive function that has been shifted right 6, down 3, and has a vertical stretch of 7. This one I forgot to mention has a vertical stretch of 5. And so with this, the whole point of this is just to make the equations look different but mean the same thing using the radical properties that we have learned. Okay, go ahead and go work on your study guide now. Thanks for watching.